Hello everyone, today we're going to talk very important topics. 5.1c. So in this sections, we're going to talk about three very important concepts about vectors. The first one we're going to talk about is the equal vectors. And the second one we're going to talk about is negative vectors. And the last one we're going to talk about is zero vectors. Okay, we're going to talk about three very important vectors. Okay, let's talk about the first one. Okay, equal. Let's talk about the first one. Okay, equal vectors. So what is equal vectors? Okay, let's talk about first one, equal vectors. Okay, so for example, we have two lines A to B at this direction, where I have another line C to D. Okay, so basically, if let's say A, B equals to 2, 1, 2, 1, and CD equals to 2, 1 also. Okay, if this is the case, so basically we are saying these two vectors are equal vectors. So which means AB equals to CD. Okay, so we see all of them is equal vector. Yeah, the equal vectors. Okay. So this is very simple, right? So basically, so let's summarize it. Two vectors are equal if they have the same magnitude and in the same direction. Okay, so this is very clear. So they have the same magnitude, and also in the same direction. Okay, so they are the equal vectors. Okay, the next one we're going to talk about is so in this case, so x. If we have x AB and y AB equals to x CD and y CD. Okay, so in this case, we can find out. Okay, x AB equals to x CD, and then y AB equal to y CD. Okay, so this is very clear, right? So we come up from here, because they are the equal vectors. If two vectors are equal if they have the same magnitude and also in the same directions. So in terms of column vectors, if these two vectors are same, so we can find out the x components of AB equals to the x component of CD, and the y component of AB equals to the y component of CD. Okay, that is very clear. Okay, let's move on to the next one. The next important concept we're going to talk about negative. So what is the negative vectors? Okay, so what is the negative vectors? On the other hand, so let's say for example we have another case. Okay, so let's say for example we have AB. Of course, AB is this direction, and then we know AB equals to 2, 1, right? So and we also have another line, but they are running different direction. So basically they are HG. Okay, so basically the starting points from G to H. So in this case, the GH equals to -2 and -1 because they're moving to the left. Two units are moving downwards for 1 unit, so it becomes -1. Okay, so basically, so we can see from here, we can see that. Okay, so basically these two vectors, we can see they are negative vectors. So we can say is AB equals to -GH. So from here we can see that we also can be summarized in this way. Okay, summarized in this way. The two vectors have the same magnitudes but in the opposite direction. Two vectors are having the same magnitude but in opposite direction. Okay, so they have the same magnitude but in the opposite direction. The magnitude is the same. Okay, the magnitude, same magnitude but have a opposite direction. Okay, and then we say, okay, then we can also say this GH is the negative vector of AB. Okay, so basically this is the thing. So of course we can write in this way. We are right here. So we say AB equals to -GH. Okay, just take note about this minus. So this is very important. Okay, now we finish the next concept is the negative vectors. Okay, we're going to move on to the number 3 is zero vectors. Okay, so what kind of conditions so we can find out the zero vectors? So what are those zero vectors? Okay, zero vectors. Okay, so for example we have 1 point. Okay, let's say for example we have A. So basically the starting point is the same as ending point, also called, maybe they have the same initial point and same terminal point, so they have the zero magnitude. So basically they have a zero magnitude. So in this case, so of course zero magnitude equals to zero displacement, right? So basically we have the zero magnitudes also become zero together because they are the same point, they never move anywhere, so they just stay here. So we call this, okay, so basically we call this kind of vectors as a zero vector. Okay, they're zero vectors. Okay, or sometimes people call it non-vectors. Okay, so this is another name. Or sometimes we can just put a zero. Okay, just write zero, something like this. Okay, that's all. So basically we talk about these three very important concepts. Okay, we talk about these three very important concepts. Also, basically we will have an example. So basically, just think about this. So remarks. So in the remarks we talk about zero vectors. So if let's say we have A to A equals to 0, so we also can be writing in this way. Okay, during our calculations we will use this thing. When you see 0, so they can just put as x component is 0, y component is 0 as well. Yeah. Alright. Okay, let's move on to example 2. Let's look at the example. Okay, so in this example 2, so we have this question. So if A equal to 7 minus 2. Okay, and then find. Okay, the first one item we're going to find is the first one we're going to find the magnitude of this A, vector A. So we can use the formula we have from this last class, Pythagoras theorem. So basically we just put this thing, okay, then we put 7 power 2 and then this minus 2 power 2. So then we will find out, okay, so basically, so this is this is 59 plus 4, right? So then we have this thing, so 53. Okay, this is the magnitude, and then B, we're going to find out the next one. We find out minus A. So minus A is the negative vector of this A. Okay, so we just put, because we know this thing, so we just put both sides, we put a negative. So, and then we just put in this negative sign inside. So it's minus 7, and then here, because this both minus to become 2. Okay, so this is the this is looking for the negative vector of negative vector. Okay, negative vector. Okay, so let's move on to the next one. Next one, we're looking at this magnitude of minus A. Okay, so we can use the same formula we have here. So minus 7 power 2 and then it's 2. Okay, so what we get? 49 plus 4 equals to 53. So we can see that they are all, okay, although they are negative vectors, but they have the same magnitudes, but the direction is different, right? They are opposite direction. Okay, next one. Okay, so if we know, minus A equals to m plus n and then minus 2n. Okay, so we need to find, if let's say we know this equation, so we're going to find out m is how much, n is how much, right? Okay, so now let's look at it here. So because we know, okay, because we know, okay, let's say first one, go, because we know minus A, the negative vector is minus A equals to minus 7, 2. Okay, so this is the things, then we know now from this equation we know m plus n minus 2m. So because we know, okay, if this two vector is an equal vector, okay, equal vector. They are the equal vectors. So from here we can just come out another one. We can see minus 7 equals to minus m plus n, and 2 equals minus 2m. Okay, so from here, then we can find out next one. So we can see the m equals to minus 1. So from here, this equation we can find out m is minus 1. And then from here, we just bring in the m to here. Okay, so they become x7 equals to minus 1 plus n. So from here we can bring out m equals to minus 1, n equals to, we bring with both sides were plus 1. So let's say plus 1 plus 1. So here will be minus 6. Right? Minus 6. Okay, so finally we see m equal to minus 1 and n equals to minus 6. Right? So it's a simple equation. Okay, so from here we finish. So from here we finish the example 2. Okay, there's a try 2. Okay, try number 2. Try it. Number 2. You can go back and do some calculations on this one. Basically, it's almost the same as this. Okay, you can try to Okay. Tomorrow, next class, we're gonna talk about 3 and 4. Okay, under the same concept. Okay. Okay, everyone, thanks for watching. So we will stop here. See you soon. Bye.